Since the beginning of time, humans have looked up at the night sky and wondered what's out there. The stars, planets, and the vast blackness have always fascinated us. But it wasn't until the 20th century that we actually found a way to leave Earth and explore beyond our world. Space exploration isn't just about sending rockets into the sky, it's about unlocking mysteries, dreaming bigger, and ensuring a future for humanity. Let's dive into how we got here, where we are now, and why the future of space exploration matters so much. The story really began in 1957 when the Soviet Union launched a small satellite called Sputnik 1 into orbit. It was just a metal sphere with 4 antennas, but it changed everything. For the first time, humans have created something that traveled beyond Earth's atmosphere. This triggered a period known as the space race, mainly between the Soviet Union and the United States. In 1961, a Soviet astronaut, Yuri Gagarin, became the first human to travel into space. Not long after, in 1969, the US achieved something truly historic. Neil Armstrong and Buzz Aldrin walked on the moon during the Apollo 11 mission. Armstrong's words, "That's one small step for man, one giant leap for mankind," became legendary. After Apollo, space programs focused more on building space stations like Mir and the International Space Station, sending robotic missions to other planets and studying the universe using satellites and telescopes. Today, we are entering a new era. NASA's Artemis program is planning to return humans to the moon, not just for a visit this time, but to stay longer and use it as a stepping stone to Mars and beyond. Artemis will send the first woman to the moon. It's the next big chapter in humanity's adventure. You might wonder, why are we so obsessed with space? Well, space represents the ultimate mystery. It's filled with questions we don't yet have answers to. Are we alone? How big is the universe? Can we live somewhere else? There is something deep inside us, a natural curiosity that pushes us to explore the unknown. It's the same instinct that made early humans cross oceans, climb mountains, and explore new lands. Space is simply the biggest new land we have ever faced. Also, space exploration challenges us to invent new technologies, push the limits of science, and imagine a future that's bigger and bolder than our present. It's not just a dream, it's a drive hardwired into who we are. Today, space exploration is a global effort involving both governments and private companies. NASA, after the shuttle era, is now focusing on returning to the moon through the Artemis missions and exploring Mars with the Perseverance rover, alongside ambitious plans for future human missions. SpaceX, founded by Elon Musk, has revolutionized space travel by developing reusable rockets like the Falcon 9 and the massive Starship, aiming to eventually transport humans to Mars. They have already begun ferrying astronauts to the International Space Station. Meanwhile, the European Space Agency is collaborating closely with NASA on missions to the Moon and Mars, while also launching some of the world's most advanced space telescopes and Earth-observing satellites. China's CNSA is advancing rapidly as well, having constructed their own space station. Tiangong landing a rover on the far side of the moon, a historic first, and sending the Zhurong rover to Mars. India's ISRO has made remarkable progress too, with the Chandrayaan missions exploring the moon, Mangalyaan achieving a successful orbit around Mars on a modest budget, and plans now underway for human spaceflight and interplanetary exploration. Private companies like Blue Origin, founded by Jeff Bezos, and Rocket Lab are also pushing the boundaries, making space tourism, asteroid mining, and private lunar missions real possibilities. In short, space is no longer dominated solely by superpowers. It is rapidly becoming an international and commercial frontier, opening up opportunities for everyone. Now, you might wonder, is all this focus on space really necessary where there are so many problems to solve on Earth? It's a fair question. However, space exploration actually helps us address challenges on Earth and prepare us for a better future. For instance, satellites provide critical data about our planet's climate, oceans, forests, and weather patterns. Without space technology, we wouldn't even grasp the full extent of climate change's impact. Moreover, space exploration plays a vital role in ensuring humanity's survival. Earth, though beautiful, is fragile, and threats like asteroid impacts, nuclear wars, pandemics, or climate disasters could endanger civilization. By becoming a multi-planetary species, settling on places like Mars or the Moon, humanity's chances of long-term survival significantly increase. Additionally, the drive to explore space fuels innovation. Technologies like GPS, advanced materials, and even medical breakthroughs have roots in space research. It also expands our perspective about our place in the cosmos. Beyond all of this, space exploration inspires generations, sparking dreams, pushing us to aim higher, and proving that no problem is unsolvable when we work together. In truth, space exploration isn't about abandoning Earth. It's about strengthening, enlightening, and uniting humanity for the future. We have come a long way since that little beep from Sputnik 1. Today, the dream of walking on Mars, building cities on the Moon, and maybe even traveling to other stars no longer sounds like science fiction. It's starting to sound like a plan. The future of space exploration is exciting, challenging, and vitally important. And the best part? Your generation, will be the ones leading the next giant leaps for mankind. The moon has always been a symbol of human ambition and curiosity. It's not just a dusty rock in the sky anymore. It's becoming a stepping stone for our future in space. As we look ahead to the near future, the moon is set to play a major role in space exploration, with NASA's Artemis program leading the way. Artemis is NASA's ambitious plan to return humans to the moon, but this time, it's not just for a brief visit. The goal is to establish a sustainable presence on the lunar surface. In the 2020s and 2030s, Artemis mission will land astronauts on the moon, including the first woman and the first person of color, marking a milestone in space history. Why is this important? Well, Artemis is more than just about going back to where Apollo 11 landed in 1969. It's about setting up a lunar base, a permanent outpost where humans can live and work. The lunar base will be a hub for scientific research, and even testing ground for new technologies that will help us explore farther, like Mars. One of the exciting parts of the Artemis program is the potential for lunar resource extraction. The moon is rich in resources that could be critical for future space missions. For instance, helium-3, a rare isotope found on the moon, could be a game changer for energy production on Earth. Helium-3 might one day be used in nuclear fusion, a cleaner, more sustainable energy source that could solve Earth's energy problems. Additionally, a lunar mining could provide water ice, which is essential for drinking, farming, and creating oxygen and rocket fuel. By extracting these resources from the moon, we could reduce the cost and need to launch everything from Earth. The moon isn't just a destination, it's becoming a resource-rich platform for future exploration. Moving beyond the moon, the next giant leap is Mars, the red planet. Mars has fascinated humans for centuries, and now we are finally gearing up to explore it in ways that were once thought impossible. The 25 to 2040 period is expected to be a defining time for Mars exploration, with plans to send astronauts to Mars becoming more tangible. SpaceX, led by Elon Musk, has made Mars the ultimate goal. Musk's vision for the future of humanity is for us to become a multi-planetary species. The key to this vision is Starship, a massive reusable spacecraft designed to carry humans to Mars. Unlike previous rockets, Starship will be fully reusable, drastically reducing the cost of interplanetary travel. SpaceX plans to send its first uncrewed mission to Mars in the late 2020s, followed by the first crewed mission in the 2030s. The mission would be the first step toward establishing a human colony on Mars. Musk envisions cities with thousands of people living on Mars, growing food, mining resources, and building the infrastructure needed to survive on the planet. NASA isn't sitting idle. While SpaceX leads the charge with its private initiatives, NASA's long-term goal is to send astronauts to Mars as part of its Journey to Mars initiative. NASA is working on developing the Space Launch System, a powerful new rocket designed to send astronauts farther into the solar system than ever before. The Orion spacecraft, which will be launched by SLS, will be the vehicle for the crew on Mars mission. However, living on Mars is not easy. The challenges are enormous. Living on Mars will be tough. The planet has a thin atmosphere, filled mostly with carbon dioxide, and surface temperature can plunge to minus 125 degrees Celsius at night. The biggest threats to human survival are radiation and the lack of resources. Unlike Earth, Mars doesn't have a magnetic field or thick atmosphere to protect its surface from cosmic radiation and solar radiation. Without proper shielding, this radiation could cause serious health issues for astronauts living on Mars. Also, while water has been discovered in the form of ice on Mars, the planet doesn't have breathable air or fertile soil. Growing food and producing oxygen will require advanced technologies like greenhouse or closed-loop life support system that recycle air, water, and waste. Psychologically, the isolation of Mars, with a trip that could take months to get there, even longer to return, will also be a significant challenge. Astronauts will have to live in confined spaces and be cut off from family and friends for long periods, which could lead to mental health challenges. The private sector is playing an increasingly pivotal role in space exploration, with companies like SpaceX, Blue Origin, Rocket Lab, and Axiom Space not only making headlines but also shaping the future of space travel. SpaceX has already revolutionized the industry with its Falcon 9 rocket and Dragon spacecraft, significantly reducing the cost of launching satellites and cargo to the International Space Station. Their Starship project aims to make human space travel to the Moon, Mars, and beyond a reality. Blue Origin, founded by Amazon's Jeff Bezos, is working on reusable rockets to make space travel more affordable and accessible to all, including through space tourism. Rocket Lab, a rising player in the field, specializes in small, cost-effective rockets perfect for launching small satellites into low Earth orbit. Meanwhile, Axiom Space is focused on developing a commercial space station, offering private companies and astronauts the opportunity to live and work in orbit, while also opening doors for research, manufacturing, and space tourism. The growth of these companies is fueling the rise of a new space economy, where private companies are not just launching satellites but also building space habitats and offering public space tourism. The future of space travel is no longer solely in the hands of government agencies but is rapidly becoming a global industry. In the near future, low Earth orbit, which is the area where the International Space Station orbits, will become a bustling hub of activity. Commercial space station will host hotels, industries, and even space tourism ventures. Imagine staying in a hotel in space, experiencing zero gravity, and looking down at Earth. It might sound like space fiction, but companies like Axiom Space are already planning to build the first private space station, offering tourists a chance to visit space. In addition to tourism, industries are setting up in space to take advantage of microgravity for manufacturing products that can't be made on Earth. Materials like fiber optics and pharmaceuticals can be produced in space with unique properties, opening up new markets and possibilities. The 2040s and 2050s will be a crucial period in the history of human space exploration. By this time, our ambition for Mars will have shifted from exploration to colonization. The first permanent human settlements on the Red Planet will be a monumental achievement, marking the beginning of humanity's journey to becoming a multi-planetary species. The first Mars colonies will be a combination of habitats, greenhouse, and energy sources, all carefully designed to sustain human life. These colonies will not just be places where astronauts stay for a few months. They will be self-sustaining ecosystems where people can live, work, and even have families. Building these settlements will require technologies we have never used before. Life support system will need to recycle air, water, and waste. Solar power will be the main source of energy and greenhouse will grow food, making the colonies less reliant on Earth. Over time, a SpaceX Starship and NASA's Mars mission establish more infrastructure. These colonies could expand into thriving communities, home to scientists, engineers, and eventually everyday people looking for a new life on Mars. A big dream for the future of Mars is the idea of terraforming, turning the planet into a more Earth-like environment. Imagine a Mars with a breathable atmosphere, liquid water on the surface, and temperature climate. This is the stuff of science fiction, but it's also something that scientists are actively researching. However, terraforming Mars is no small task. The atmosphere on Mars is 100 times thinner than Earth's and is made mostly of carbon dioxide, which means it's impossible to breathe without a spacesuit. While some ideas have been proposed, such as using greenhouse gases to warm the planet or building giant mirrors in space to reflect more sunlight onto Mars, the truth is that it will take centuries or even millennia before Mars could even begin to resemble Earth. Instead, the focus will likely be on creating small, enclosed habitable areas, domes or underground bases where humans can survive for the foreseeable future. Terraforming might still be a dream, but human survival on Mars is becoming more and more realistic. While Mars may be our next home, asteroids are where the future of space resources lies. Floating in space between Mars and Jupiter, asteroids are often referred to as the gold mines of the solar system. Why? Because they are packed with valuable metals, water, and other resources that could be crucial for life on other planets. Asteroids are incredibly rich in materials like nickel, iron, platinum, and even gold, materials that are in high demand on Earth. But the most important resource in asteroid is water. Water is essential for life, and it can be used for drinking, growing food, and producing hydrogen and oxygen for rocket fuel. In space, water is not just a resource, it's a lifeline. Extracting water from asteroids could reduce the need to transport it from Earth, which would make long-term space missions more affordable. In the 2040s and 2050s, asteroid mining will be a booming industry. Private companies like Planetary Resources and Deep Space Industries are already planning missions to explore and mine asteroids for their valuable resources. These companies will send robots to asteroids to mine and process materials, which can then be sent back to Earth or used in space. Not only will asteroid mining provide resources for Earth, but it could also support the building of space colonies. Space-based manufacturing, making things like spacecraft, solar panels, and fuel will be much easier if we can source the materials right from space rather than Earth. As humanity aims to explore more distant parts of the solar system and even beyond, new and more advanced propulsion technologies will be developed to make space travel faster and more efficient. Some of these technologies are already in the works, while others are more speculative. One of the most promising advancements is nuclear thermal propulsion. This technology uses nuclear reactions to heat a propellant, which is then expelled at high speeds to create thrust. Unlike conventional chemical rockets, nuclear thermal propulsion is more efficient and could reduce travel time to Mars by several months. This could make it easier to send astronauts to Mars and beyond without requiring them to be in space for extended periods. Another exciting propulsion technology is solar sails. These sails are made of large ultra-thin materials that capture photons from the sun. As light hits the sails, it pushes them forward. Over time, this gentle push could accelerate a spacecraft to speeds that chemical rockets can't achieve. Solar sails could enable spacecraft to travel farther into the solar system and even beyond, taking us on missions to distant asteroids, outer planets, and maybe even other star systems. For more efficient travel in deep space, ion engines will play a key role. Ion engines work by expelling charged particles at extremely high speeds to generate thrust. While ion engines produce less thrust than chemical rockets, they are much more efficient and can run for a long time. making them ideal for long duration missions to places like Jupiter and Saturn. In the far off future, we may see even more exotic propulsion technologies like antimatter or theoretical drives such as the Alcubierre drive. These technologies sounds like science fiction, but they could one day allow us to travel to speeds approaching the speed of light, making interstellar travel possible. Artificial intelligence and robotics will be central to space exploration in the medium-term future. As we venture deeper into space, sending humans will become increasingly difficult and dangerous, but AI and robots will be able to explore, build, and even colonize on our behalf. Before humans can set foot on distant worlds like Mars, AI explorers will be sent to scout and map the terrain. These robotic probes will be able to navigate harsh environments, collect samples, and analyze data without needing human intervention. For instance, AI could be used to identify the best locations for building colonies on Mars or detect water ice on distant moons like Europa. Robots will also be critical for mining and construction on other worlds. On Mars, for example, robotic mining machines could extract valuable minerals and water from the surface, while construction robots could help build habitats and infrastructure. These robots will be able to work in environments that are too dangerous for humans and can operate around the clock, speeding up the process of colonization and resource extraction. As humanity spreads out into space, the question of who owns space resources and how space will be governed becomes more important. Right now, space law is based on international treaties, but the rapid development of private space companies and the possibility of mining asteroids and setting up colonies will create new challenges. One of the biggest questions will be who owns the resources in space. Under current international space law, the moon and other celestial bodies are considered to be part of the global commons, meaning they belong to no one country. However, if a private company mines an asteroid and finds valuable resources, who gets to keep them? This is an area of ongoing debate, and as asteroid mining becomes more feasible, governments and private companies will need to establish clearer laws. As more countries and companies venture into space, there could be conflicts over resources or territory. Imagine if two companies wanted to mine the same asteroid, or if two countries set up colonies on Mars in overlapping areas. To prevent conflicts, international treaties and agreements will be necessary, similar to how countries today have agreements on ocean resources or Antarctica. The goal would be to ensure that space is used peacefully and that no one nation or corporation dominates. Finally, with the rapid development of space technologies, there is the issue of space security. Space is no longer just a place for exploration, it's becoming a place for strategic and military operations as well. In the 2020s and 2030s, countries like the United States formed their own Space Force, a branch of the military dedicated to protecting space assets. As space becomes more crowded with satellites, space stations, and other infrastructures, the risk of militarization increases. Countries may begin developing weapons designed to defend or attack satellites, which could lead to an arms race in space. Kinetic weapons, which are designed to destroy satellites using force rather than explosives, could be used to disable a rival's communications or military satellites. Additionally, satellite hacking could become a major threat where cybercriminals or even nations could take control of satellites' functions, causing disruptions to communication, navigation, or even space station operations. As humanity moves further into space, ensuring the security of these assets will be as important as any other aspect of space exploration. The medium term future of space exploration is filled with possibilities. From Mars colonies to asteroid mining to breakthroughs in propulsion technologies and AI, the next 30 to 50 years will be a time of incredible progress. But with these advancements come new challenges, including questions about space law and the militarization of space. As we push further into the cosmos, humanity will need to balance its ambition with the responsibility of sharing space peacefully and securely. By the end of the 21st century and into the next few centuries, humanity's vision of space exploration will evolve from isolated missions and small colonies to the formation of a true interplanetary civilization. This will involve the establishment of self-sustaining colonies on planets and moons across our solar system, the creation of interplanetary trade routes, and the development of technologies that will allow humans to thrive on multiple worlds. The Moon and Mars will no longer be just research outposts. They will become bustling hubs of human civilization. By 2075, the first settlements on Mars will have grown into large self-sustaining colonies. These colonies will be able to grow their own food, produce energy, and have advanced technologies that enable them to survive for centuries without needing frequent resupply missions from Earth. In addition to Mars, the Moon will serve as an essential base for resource extraction and space exploration. With its proximity to Earth, the Moon will likely become the staging point for missions to more distant worlds, while also acting as a mining hub for valuable resources like helium-3 for fusion energy. By the time we reach the 22nd century, humans may have expanded to other celestial bodies in the solar system, creating colonies on Venus, floating cities in the upper atmosphere where the environment is more hospitable than the planet's surface, or on the moons of Jupiter and Saturn. As humanity establishes colonies on multiple worlds, the need for interplanetary trade will become crucial. Much like how Earth's early civilization established trade routes across continents, future spacefaring civilizations will set up trade routes across the solar system. Spacecraft, cargo ships, and supply lines will regularly travel between Mars, the Moon, and other colonies. These routes will facilitate the exchange of resources, knowledge, and culture. Imagine a bustling trade system where materials from Mars are shipped to the Moon for processing or used to construct new colonies on Titan. Hydrogen, mined from Jupiter moons, could be sent to colonies in the outer solar system, while water from asteroids or Europa will be essential to life in these colonies. The creation of such trade routes will require advances in propulsion technology, infrastructure, and spacecraft design, turning the solar system into a large interconnected network of human settlements and economic activity. While the Moon and Mars will be humanity's primary stepping stones, there are other more exotic destinations in our solar system that could become humanity's next frontiers. The outer moons of Jupiter and Saturn, Titan, Europa, and Ganymede, are particularly enticing because they may offer the potential for long-term colonization. Titan, Saturn's largest moon, is the most Earth-like body in the solar system. With a thick atmosphere and lakes of liquid methane, Titan is a prime candidate for exploration and colonization. While its surface is cold and its atmosphere is not breathable, Titan's unique environment offers exciting possibilities. Scientists envision floating cities above its dense atmosphere where humans could live and thrive in specially designed habitats. Titan could serve as a base for mining hydrocarbons or harvesting its abundant nitrogen, which could be used to create breathable air for other colonies in the outer solar system. The moons of Jupiter, Europa, and Ganymede also hold the potential for human colonization. These moons have subsurface oceans beneath their icy crust which could harbor microbial life or at least be a source of water for human colonies. Europa is especially intriguing because its ocean is in contact with the moon's rocky mantle, which could provide the necessary chemical ingredients for life. A colony on Europa would likely be built on or under the surface using advanced techniques to drill through the ice and reach the ocean beneath. Ganymede, the largest moon in the solar system, has a magnetic field and abundant resources, making it a prime candidate for settlement as well. For humanity, establishing colonies on these moons would mean facing the challenge of surviving in extreme cold and dealing with radiation from Jupiter's intense magnetic field. However, the resources and potential for life below the ice could make it worth the effort. One of the greatest quests of humanity in the long-term future will be the search for alien life. As we push deeper into space, we will build more advanced telescopes and send out more probes, all with the goal of answering one of humanity's most profound questions: are we alone in the universe? The search for extraterrestrial intelligence will continue to evolve as new telescopes and space observatories come online. By 2075, we will have next-generation instruments capable of searching for signs of life around distant stars, far beyond what we are able to study today. The successors to the James Webb Space Telescope, for example, will have even greater resolution and sensitivity, allowing us to study exoplanets, planets which are orbiting outside our solar system. We will search for biosignatures, the chemical signs of life in the atmosphere of planets around distant stars. This could include the detection of oxygen, methane, and other gases that might indicate the presence of life. The hope is that we will eventually find planets with conditions similar to Earth, where life as we know it, or even life we can't yet imagine, could be thriving. As we search for alien life, a major focus will be finding biosignatures on exoplanets, planets in the habitable zone of their stars where liquid water can exist will be prime targets. The future of exoplanet exploration will involve sending advanced telescopes to detect the chemical composition of these planets' atmospheres. If we find oxygen or methane in their atmospheres, it could be a sign that biological processes are taking place on these distant worlds. Finding alien life would be one of the greatest milestones in human history, radically changing our understanding of life, the universe, and our place in it. It would spark a new era of interstellar exploration as we seek out other habitable worlds. In the far future, humanity may not only explore our solar system but also begin reaching for the stars. The idea of sending probes to other star systems has been a long-standing dream, and with advances in technology, it could become a reality by the end of 21st century or the early 22nd century. One of the most ambitious projects in the search for interstellar exploration is the Breakthrough Starshot initiative. This project aims to send small, light-powered spacecraft known as starships to Alpha Centauri, the closest star system to Earth, in just 20 years. These tiny spacecrafts would be propelled by laser beams sent from Earth, allowing them to travel at a significant fraction of the speed of light. While the Breakthrough Starshot project is still in its early stage, it represents a major step in humanity's desire to reach beyond our solar system. If successful, it could take just 20 years for these tiny spacecraft to reach Alpha Centauri and send back valuable data about exoplanets in that star system, potentially including evidence of alien life. The Voyager probes launched in the 1970s are humanity's farthest traveling spacecraft. As of the 2070s, Voyager 1 and Voyager 2 will be sending data back to Earth even though they will be far beyond the influence of the Sun. These spacecraft represent the beginning of humanity's journey into interstellar space. By the end of the 21st century and into the 22nd century, new, more advanced spacecraft will follow in Voyager's footsteps, carrying humanity's message into the stars and exploring the outer regions of the Milky Way galaxy. The long-term future of space exploration promises to be even more exciting and transformative than what we have seen so far. From interplanetary civilization on Mars and the Moon to the search for alien life on distant exoplanets, humanity's future in space will be filled with new challenges and discoveries. As we push beyond the limits of our solar system, we may one day reach the stars themselves, opening up new frontiers for exploration and perhaps even discovering that we are not alone in the vastness of space. As we venture into the 22nd century and beyond, humanity's dream won't stop at Mars, the outer moons, or even nearby star systems. Our ambitions will turn to ultimate question: how do we survive across thousands of years? How do we travel across the galaxy? What will we become as a species? This chapter is where science starts to blend with imagination, rooted in real theories but often stretching far beyond our current capabilities. Let's dive into the ultimate future of space exploration. The nearest star system, Alpha Centauri, lies over 4 light years away. With today's fastest spacecraft, the journey could take tens of thousands of years. How can we even begin to think about colonizing other star systems? One proposal is the idea of generation ships. Picture a massive spacecraft, essentially a floating city with farms, water recycling, energy systems, and homes people would live, work, and raise families aboard. Entire generation would be born, live, and die, never seeing Earth or the final destination. Such voyages could last hundreds or even thousands of years. The ship must be completely self-sufficient, growing its own food, repairing itself, and maintaining life support indefinitely. It would house a miniature Earth, plants, animals, insects, everything necessary for survival. These generation ships would act as humanity's arks, ferrying civilization through the dark ocean of interstellar space in search of new worlds. Traveling for centuries is hardly ideal. If we could master faster than light travel, other star systems could possibly be accessible within days or weeks. However, Einstein's theory of relativity tells us that nothing with mass can travel faster than light. So instead, scientists imagine bending the rules of the universe. One notable concept is the Alcubierre drive, proposed by physicist Miguel Alcubierre. Rather than moving faster than light, the drive would warp space itself, contracting space ahead and expanding it behind the ship, creating a bubble moving through the universe. Within the bubble, the ship wouldn't technically exceed light speed. Space itself would move. It's a fascinating idea, but it's purely theoretical and would require exotic matter with negative energy, something still undiscovered. Another idea involves wormhole, based on solutions to Einstein equations. A wormhole or Einstein-Rosen bridge act as a shortcut through spacetime connecting two distant points instantaneously. Picture folding a piece of paper and poking a hole through it. That's the essence of a wormhole. But major challenges exist. They might collapse instantly, be too small for humans to travel, or expose travelers to fatal radiation. Still, if someday we learn to stabilize wormholes, it could revolutionize space travel forever. Beyond exploration, the future might involve cosmic scale engineering. One vision is the Dyson sphere, named after physicist Freeman Dyson. It involves constructing a structure around a star to capture all its energy output. A rigid shell is likely impossible, but swarms of orbiting stars collectors could serve a similar purpose, harvesting and transmitting the star's energy. Building a Dyson sphere would place humanity on the Kardashev scale. Type 1 harness all energy on its planet. Type 2 harness all energy of its star. Type 3 harness all energy of an entire galaxy. Currently, humanity is about 0.7 on this scale. Yet, one day, megastructures like Dyson spheres might be essential for survival and thriving among the stars. The brutal reality is that human bodies are not built for deep space. Cosmic radiation, psychological isolation, and aging present enormous challenges. One potential solution: abandon the body. Futurists speculate that humanity might eventually upload consciousness into machines. Instead of fragile biological humans, we could send digital minds into space. Imagine exploring the galaxy as digital beings, living in robotic bodies, or as pure information traveling across networks spanning the stars. This digital immortality could enable humans to travel for millions of years, evolving into entirely new life forms. It would represent the ultimate evolution, from biological beings to post-biological life, better adapted for the endless journey across the cosmos. As we reach the end of our journey through the future of space exploration, it's time to step back and ask a deeper question. Why does any of this matter? Why are we so drawn to the stars? Why have humans, since the dawn of civilization, gazed at the night sky and dreamed of touching the heavens? The answer goes beyond rockets, spacesuits, and satellites. Space exploration defines who we are. We are a species of explorers. From the moment early humans walked out of Africa to settle every corner of the earth, exploration has been woven into our DNA. We cross oceans, climb mountains, dive into the deepest seas, not because it's easy, but because the unknown calls to us. Space is the ultimate unknown, and by reaching for it, we affirm the best part of ourselves, our curiosity, our courage, and our desire to create something greater than ourselves. Think about it. 100 years ago, airplanes were rare and fragile inventions. 60 years ago, the idea of walking on the moon sounded like pure science fiction. 30 years ago, the idea of sending a car to Mars or building private rockets was laughable. Yet, Here we are today, building rockets that can land themselves, planning mission to Mars, and imagining cities among the stars. Every breakthrough began as a dream, and every dream began as a crazy idea someone dared to believe in. Today's impossible visions, generation ships, warp drives, Dyson spheres may seem like fantasy. But if history teaches us anything, it's that impossibility is often just a matter of time. The future belongs to those who dream and then work to turn those dreams into reality. But if we truly want to become a spacefaring civilization, there is a critical lesson we must learn. We must choose cooperation over competition. For too long, space has been treated as a race, a contest of national pride, military power, and economic domination. But the universe is too vast and the challenges too great for any one country or company to do it alone. Colonizing Mars, building lunar bases, sending probes to distant stars, these tasks will require the combined genius, effort, and spirit of all humanity. When we look at Earth from space, borders vanish. There are no lines dividing nations, no flags, no armies, just one small, fragile world spinning in the endless dark. We are not Russians, Americans, Chinese, Indians. We are Earthlings. And the stars will not be won by nations, but by a united species. Space is not just our destination, it's our destiny. One day, if we survive and thrive, humanity will be a multi-planetary species. Children will be born on Mars, cities will float in the cloud of Venus, ships will sail between moons and asteroids like ancient caravans cross deserts. And when those future generations look back on us, they will see this moment, the 21st century, as the beginning. The beginning of humanity's greatest journey. The beginning of a story not limited to one planet but written across the stars. So let us dream boldly, let us work tirelessly, and let us remember the universe is vast, but so is human potential. Our future is out there, waiting. All we have to do is reach for it.